We have a horizontal rod and an ant at one end of the rod. But to the question, where is the ant, you would say at the end of the rod. If you want to be a little more formal, you can say O is the origin and the x-coordinate of the ant is 0. If the ant moved, say, some 30 centimeter on the rod, so the x-coordinate, new x-coordinate of the ant would be 30 centimeter. This x-coordinate is measured with reference to O. O is the origin. This is a reference frame attached to the rod. We need only x-axis here because the ant is moving in a horizontal direction and our x-axis towards east. So the change in the x-coordinate is 30 centimeters. So ant has moved 30 centimeter, well, to the east, you would say. So to deal with positions, you need an origin and an axis, or maybe more than one axis if it is two-dimensional motion or three-dimensional motion. Now, so as the ant moves on the rod also moves. How to deal with the rod's motion? You could choose an origin O dash, which is a fixed point on the board or in the room, and measure the position of the end of the rod at the initial moment, that is x-coordinate x dash, say, is 0. This prime is being used to deal with the rod's motion. So the rod has moved 10 centimeters, new end of the rod has a new x-coordinate of 10 centimeter. So, and in the meanwhile, as the rod was moving, the ant also was moving, so the ant is here now. So for measuring the position of the ant, we are using the origin O. For measuring the position of the rod, we are using the origin O dash. So there are two reference frames here. These are only one single x-axis. Say, so what is the displacement of the ant? You would say displacement of the ant is 30 centimeters on the rod, and that's okay if you are referring to only the rod. But if you want the displacement of the ant relative to the, say, board, relative to the ground, this O dash is at rest related to the ground. So you would have to add that. So displacement of the ant related to the rod plus displacement of the rod gives us the displacement of the ant. We are not using ground observer here. We should have done that. Ground observer. Ground observer is generally the standard observer for all motion that we analyze. We typically use ground observer. So there should have been ground observer board here, which we are not writing. This is well and good if it's a simple straight line motion. Algebra would be enough. If the rod had moved, say, to the west, you would have put a minus sign for displacement of the rod. So east is positive, west is negative, and that would take care of the, well, displacement of the ant. If you are basically dealing with what is the change in position of the ant. So basically we have two reference frames here. One reference frame to deal with the rod's motion, another reference frame to deal with the ant's motion on the rod. And we say this reference frame is attached to the rod, and that's O and x-axis, and this O dash is attached to the ground or to the board. Supposing the rod moved vertically up as the ant was moving on it, say the rod moved, say, some 40 centimeter during the time the ant walked on it 30 centimeter. This is 40 centimeter. The displacement to the end of the rod. Again, we have an origin O dash coinciding with O. So the y coordinate of the end of the rod was 0. Now y coordinate is 40 centimeter. So delta y is the change in y coordinate of the end of the rod measured with reference to O dash here, right? So O is attached to the rod. So what is the displacement of the ant? Well, relative to the rod, this is 30 centimeter east. So we need an x-axis and a y-axis now. Let's orient y-axis vertically up. This is our y-axis and this is our x-axis. The axes are parallel here, that is x and y axis attached to the rod and x and y axis attached to the board are parallel. So this displacement ant related to the rod is 30 centimeter. Well, we'll put a bar on that and 30 I bar centimeter. Displacement of the rod is 40 centimeter, that's 40 J bar, that's in the y direction. Now what is the displacement of the ant related to the board? This is related to the board, related to the ground. What is the displacement of the ant? You would say displacement of the ant related to the rod plus displacement of the rod. So that's it. We have a relation between displacement of two different reference frames. We need x and y axis here. So then, you have to add the motion of the rod to the motion of the ant related to the rod. So the rod has moved, the ant has moved related to the rod. So in addition to the rod's motion, we have some motion of the ant on the rod. So that's what we have done here. And then supposing as the ant started moving, the rod also started moving. So the ant arrived at this position at the same time as the rod arrived at that position. So they have taken the same time. So we could divide this by time and get the velocity relation. Velocity of the ant related to the board is velocity of the ant related to the rod plus velocity of the rod. So mind you, you are watching the ant moving on the rod and the rod moving. So related to the board, you are the observer, let's say at rest related to the board. And you are watching two things moving. So you have information about how the ant is moving on the rod and then how the rod is moving. So you got to add the rod's motion to the ant's motion related to the rod to get the ant's motion related to you, related to the board. Well, that's as simple as that. Well, when ant is moving on the rod, when we deal with its motion, we are not bothered about the rod's motion. We ignore that when dealing with ant's motion on the rod. We are interested in where is the ant on the rod. But when you are interested in the motion related to you, you see the rod also moving. You have to add its motion to that of the ant's motion on the rod. Say you are on the rooftop of your building in the early morning and you watch the rising sun. Well, in the evening, if you go onto the rooftop and watch the sun, well, sun's position is changed. That is changed related to the building. So you would say the sun has moved from east to west, it's gone round. So we are talking of the motion of the sun related to an observer on the earth. Since we do not know that the earth is moving, we got to know that earth is moving much later. Well, it seemed for a long time that sun is going around us. We never realized that earth is rotating on its axis. So the point we are trying to say here is the observer here, well, he did not know that he is moving. He thought that sun is moving. That's the nature of observation. Well, an observer imagines himself to be at rest and assumes that the objects that he observes has his reversed velocity. Right? So we have another situation. Let's say we are, wind is still and there is a car at rest. If you hold a kerchief or something out of the window, it would stay limp. It wouldn't flutter. And the wind is still, and if the car moves, say, northward, the kerchief flutters as if the wind is blowing towards south. That is, if the car were at rest and if the wind were blowing south, and if we held the kerchief, the behavior of the kerchief would be same as if the wind is at rest and the person is moving in the car towards north. So the observer, that's the person in the car, well, senses that the wind is blowing southward. But suppose wind is blowing eastward, wind is blowing eastward, and the car starts moving northward. Then if you hold that kerchief out of the window, it behaves as if the wind is blowing southeast. So because the motion of the car towards north, it seems as if the wind is blowing southward, plus the wind itself has eastward motion, so it seems like a southeast motion. So this is the velocity of the car, and this is the velocity of the wind. This is north, this is horizontal plane, this is north, and this is east. So north and east. So wind is blowing to the east. So what are we doing here? Because the observer in the car assumes that the wind has its reversed velocity. So this is, it seems to him like this. So this is the velocity of the wind, and this is the velocity of the car, which is reversed. So to know how the wind seems to blow to the person in the car, you are reversing the velocity of the car and then adding it to wind's velocity, which seems something like this. Let's see, these velocities are equal. This will be southeast. So what is the velocity of the wind related to the car? That's the question we are trying to ask. That is velocity of the wind, to which you are adding the reversed velocity of the car. I would like to say subtraction, but I would like to say adding the reversed velocity of the car. That's to the observer in the car, it seems like the wind is blowing, well, southwards because of his northward motion, but wind itself is blowing, well, towards east. This eastward motion of the wind and northward motion of the car as seen by an observer who is at rest on the ground. So an observer on the ground sees wind blowing eastward, car moving northward. The observer in the car sees, right, that the wind is blowing southeast. So reversed velocity of the car is being added to the velocity of the wind. This is the nature of observation. Observers imagine they are at rest and assume the objects that they are observing have their reversed velocity.